This is day 20 of Advent of Cyber 2025, and this challenge is called Race Conditions Toy to the World. The Best Festival Company has launched its limited edition sleigh toy. Only 10 pieces available at midnight. Within seconds, thousands rushed to buy one. But something strange happened. More than 10 lucky customers received confirmation emails stating that their orders were successful. Confusion spread fast. How could everyone have bought the last toy? Skitty was called in to investigate. She quickly noticed that multiple buyers purchased at the exact moment, slipping through the system's timing flaw. So Carapane's mischievous bandit bunnies had found a way to exploit the chaos, flooding the checkout with rapid clicks. By morning, TBFC faced angry shoppers, missing stock, and a mystery that revealed just how dangerous a few milliseconds could be during the holiday rush. The learning objectives for this are to understand what race conditions are, how they can affect web applications, learn how to identify and exploit race conditions in web requests, how concurrent requests can manipulate stock or transaction values, and explore simple mitigation techniques to prevent race conditions vulnerabilities. So for this, we need to turn the virtual machine and attack box on. A race condition happens when two or more actions occur at the same time and the system's outcome depends on the order in which they finish. In web applications, this often happens when multiple users or automated requests simultaneously access or modify shared resources, such as inventory or account balances. If proper synchronization isn't in place, this can lead to unexpected results, such as duplicate transactions, oversold items, or unauthorized data changes. Generally, race condition attacks can be divided into three categories: time of check to time of use. A TOC/TOU race condition happens when a program checks something first and uses it later, but the data changes in between. This means what was true at the time of the check might no longer be true when the action happens. Like checking if a toy is in stock, by the time you click buy, someone else has already bought it. For example, two users buy the same last item at the same time, so stock was checked before it was updated. Shared resource. This occurs when multiple users or systems try to change the same data simultaneously without proper control. Since both updates happen together, the final result depends on which one finishes last, creating confusion. Think of two cashiers updating the same inventory spreadsheet at once, and one overrides the other's work. Atomicity violation. An atomic operation should happen all at once, either fully done or not at all. When parts of a process run separately, another request can sneak in between and cause inconsistent results. Like paying for an item, but before the system confirms it, someone else changes the price. For example, a payment is recorded, but the order confirmation fails because another request interrupts the process. Okay, so with the attack box up, we want to open up Firefox, and we want to make Firefox route through Burp Suite. So select the extension icon up here, and with that selected, we then open up Burp Suite by opening up this blue iconed application. And once it's loaded up, we keep it on temporary project in memory. Click next, and we use the default settings and start Burp. Okay, so once the application started, you'll see the following screen where you'll see proxy and repeater options to exploit the race condition. We've got proxy up here, then repeat up here. Before proceeding, ensure that you turn off intercept in Burp Suite. Go to the proxy tab, and then in the intercept tab, we turn it off. So making a legitimate request. Now that the environment is configured, make a normal request in Firefox by opening up the web app at the IP address of the virtual machine. We go back to Firefox, and in the tab, we put in the IP there, and it's telling us user credentials of attacker and the password attacker at 123. So now that we are logged in, we are at the main dashboard. So to make a legitimate purchase, click add to cart, and you go to the checkout and confirm pay, and then go to orders. You can see that order has been made. Now that there's 10 stock before, stock after is now 9. If we go back to shop, we want to now open up Burp Suite, go to proxy HTTP history, and find the post request to the /process checkout. You can see here, process checkout. What we want to do is right click it and send to repeater. So in the repeater tab, you should see right here, we've got this tab number 1, which was for process checkout. It's saying to right click on the tab and add tab to group and create tab group. And we'll call it cart, create that group, then right click request tab and select duplicate tab, and saying, for example, put in 15, so we can do that. Now I've got 16 tabs of that, and then next use the repeated toolbar to send group in parallel. Send group in parallel, last byte sync. Then if we click it, it's going to launch it all at once. Let's look at, it was able to get the stock after down to -7, but all of these ran when stock levels were at 9. So I had 9 to begin with, Once it finished executing, it was now down into the negatives. So if we go back to Firefox and we refresh the page, you can see that Slateway Limited Edition has been oversold and is at -7, and also the first flag has been found here, which we'll copy and paste to here. So, mitigation. The attacker logged in and made a normal purchase of the limited Slateway. Using Burp Suite, he captured the checkout request and sent it multiple times in parallel. Because the app didn't handle simultaneous checkouts correctly, each request succeeded before the stock could update. This allowed the attacker to buy more toys than available, resulting in a race condition and pushing stock into negative values. Here are a few mitigation measures to avoid the vulnerability. Use atomic database transactions, so stock deduction and order creation execute as a single consistent operation. Perform a final stock validation right before committing the transaction to prevent overselling. Implement idempotency keys for checkout requests to ensure duplicates aren't processed multiple times, and apply rate limiting or concurrency controls to block repeated checkout attempts from the same user or session. Alright, so now we're going to do the same thing, but with the bunny plush. We'll first make one actual order of that. We will go back to Burp. Let's minimize that cart. Then go to proxy, and then HTTP history. So scroll down to the bottom for this process checkout. Should be the most recent one that we made. Grab that center repeater. Once again, we will add a tab to group. Let's just call it cart2. We will then right click it, duplicate, keep it as 15, and then we'll do the same thing by going to the tab drop down, selecting send group in parallel, and then running all of these in parallel. So with that done, we go back to Firefox, go back to the main page of the shop, we'll refresh it, and we can see the bunny plush blue was oversold, and we have the second flag. So we can copy that, paste that into here, and that is that complete. So that was day 20 of Advent of Cyber 2025 complete. Like this video, make sure to like and subscribe.